Okay, guys, can I get everyone's butt in their seats now for our next speakers? I promise we will get a break in a little bit. Okay, guys, welcome back. I hope everyone got to top up on their caffeine and you're ready to delve back in. Our speaker lineup this year is full of experts who are gracious enough to share their knowledge. So next up we have Andrew Pruski. I'm pretty sure I've absolutely butchered that last name and I do apologize in advance. Pruski? Okay, yeah, Andrew. A seasoned SQL Server DBA who's been in the game for over 15 years, a true MVP, and I'm really not kidding when I say this. Andrew is recognized as a Microsoft Data Platform MVP, Docker Captain, and VMware vExpert, and deeply immersed in the tech community. He's been described as knowledgeable, professional, and dedicated with an immense attention to detail, always to be relied upon to find the answer, and that's if he doesn't already know it himself. And a sharer as well, because he's never hogged the information to himself, and as seen in his blog as well as being a sought-after speaker. His can-do attitude is infectious and inspiring, so no wonder he's an MVP. But enough dilly-dallying, singing his praises. Let's welcome to the ShipIcon stage for 2025, Andrew Pruski.
Hello, hello, good morning, Thank you very much, and welcome everyone to this session on building resilient systems with chaos engineering. Just a little bit about myself. I'm a principal field solutions architect at Pure Storage, but before that, I was a SQL Server DBA for my sins for around 15 years. I'm originally from Swansea in Wales, but have been living in Dublin here, I would say Dublin Island, Dublin, for the last 13 years. I'm, Microsoft Data Platform MVP, Docker Captain, VMware vExpert. Basically, all-round nerd is what you can get from that. My contact details are on the slide there. At dbafromthecold.com on Blue Sky. We don't talk about the other social media platform anymore, ever since you know who did you know what. My email address is there as well, dbafromthecold@gmail.com. So if you have any questions after today, please feel free to reach out. I'm always willing to talk about this stuff. My blog's there as well, posted multiple articles about chaos engineering, running SQL Server containers, Kubernetes, VMware, anything I find interesting, you're more than welcome to check that out. But the last link there is my GitHub account. All the slides and a whole bunch of chaos engineering resources are in a GitHub repo, and I will post a link to the exact repo at the end. But anyway, on to the session. What are we doing today? We are going to talk about chaos engineering, what it is, the methodologies behind it, and importantly, what it is not, because there are some misconceptions out there. We'll have a look at some implementations at various companies, and then we will go into how we can identify chaos engineering experiments to run in our own environments. And then we'll look at an example implementation. Engineering is a discipline of experimenting upon a system to see how it reacts when it encounters failures or turbulent conditions. Do these systems react the way we expect them to, or does something else happen? If something else happens, then we need to go and analyze the results of our experiments to find out what went wrong, maybe make some configuration changes, apply them to our environment, and then run the test again. If then that system reacts to failure the way we expect it to, it builds confidence in our system that we know that it will react the way we expect it to when it encounters failures. Because we are not hoping that they work as expected, because hope is not a strategy. We do not hope things will always work out the way we intend them to. We work in IT. We work in turbulent conditions. We're constantly releasing, we're constantly deploying. Things are constantly changing. And so we need to make sure that, say, the high availability solutions or the disaster recovery systems that we put in place will work when we really need them. So let's also talk about what chaos engineering is not. Because as I mentioned, there are a few misconceptions out there. And the first one is breaking things in production. We are not here to break things in production. If I said to my manager, hey, we're going to start experiencing some more Sev1 outages now, because I am an engineer of chaos, I'd get booted out the door pretty darn quickly. We're not here to do that. And we're not here to also randomly cause outages. Chaos engineering is not running into a server room and ripping out cables and going, hey, chaos. No, we are designing specific experiments to test individual things to see how they react to those turbulent conditions. One-time test. Okay, we put a disaster recovery strategy in place. We've tested it 6 months ago. Is it still going to work? You sure? Are you hoping it's going to work? These things are not one-off tests. We are constantly running these tests in our environment all the time, building up confidence that they will react the way we expect them to when they encounter failures. Specific tooling. If you go online and have a look at chaos engineering, you'll see a whole bunch of tools out there. There's loads of them. But it's not about individual tools. Use the tools that you are comfortable with. I am a terrible Python developer. I am awful. Should I be using Python scripts to run my chaos engineering experiments? No. All that will happen will be disaster. I can read Python, I can't really write it, I can't triage it. So guess what happens if something goes wrong during chaos engineering experiment that's written in Python and I'm running it? Disaster's going to happen. I might be terrible at Python, but I'm pretty nifty with PowerShell. So maybe I write my test in PowerShell. It's not about a specific set of tools, it's about the tooling that you are most comfortable with. And the final one, only run in production. Should we, when we start designing our experiments, immediately deploy these things into production? Is that a good idea? No. Do we even need to run in production at all? No. However, if we are running in different environments, development, staging, QA, pre-prod, then we need to get those environments as close to production as we can. Okay, I'm talking from a database perspective here. We might not get the size of database or the throughput in the lower environments that we would in the production environment, but we can definitely get the same configs in there. For example, if we are running some sort of HA solution for SQL Server, availability groups, primary node, secondary node. Primary node fails, secondary node takes over. We have that in production. We don't want to run our tests immediately in production, so we run them in staging. So we should have the same setup there with the same configuration, a primary and a secondary, that we can run our tests in before we go into production, so we can be reasonably sure that we will get the same results. Okay, so let's have a look at some chaos engineering implementations. And let's start where actually it all started. Who here has heard of Chaos Monkey? We got quite a few in here, cool. Chaos Monkey. Okay, so in August 2008, Netflix experienced a 3-day outage due to database corruption. And this is back when they were starting to stream, but they were still sending DVDs out to people. So they were down for 3 days, pretty bad. Not as bad as it would be if Netflix went down for 3 days now. Could you imagine if Netflix went down for 3 days during the pandemic? There'd have been riots. Anyway, after the dust settled, they analyzed what was going on, and they decided to move away from a traditional monolithic infrastructure in a private data center to a distributed architecture in the cloud, AWS in particular. And when they went to the cloud, they adopted the mindset of, in order to prevent failures, we will constantly fail. And out of that mindset came Chaos Monkey. Chaos Monkey's sole purpose is to go through the environment, their production environment, and switch things off. The idea being here is if their systems that they're deploying cannot handle a semi-controlled outage, how are they going to handle an uncontrolled outage? It forces their developers, their engineers, to build resiliency into the systems that they deploy. Now, it's free, it's open source, it's on GitHub, you can grab it there, you can download it, and you can deploy it to your environment. I highly recommend you don't do that. If I get any emails after today saying, hey, you said I could deploy Chaos Monkey to my production environment, and now everything's down, you're not going to get a lot of sympathy from me. But it's there, go and check it out, have a look at it. However, Chaos Monkey is just a tool. Chaos engineering is more a methodology, a mindset. So let's have a look at some other implementations with Slack and Google. Slack, disaster peace theater, and Google, disaster recovery testing, abbreviated to DIRT, really? Anyway, whatever. But these aren't specific tools. These are gathering groups of engineers together to talk about how the systems are going to fail and how they can test those failures. So running in development and then production to build confidence with Slack. Hope is not a strategy is the SRE team motto at Google. Automated and manual tests. So we have tests running automatically, but we also run, say, game days, where we can actually sit a group of engineers together and test failures manually. And then finally, I love it, the controlled chaos. Controlled chaos. As I said right at the start, we're not running into server rooms, ripping cables out, and then going, ha-ha, chaos. No, we are designing specific experiments to test individual failures. Cool. So let's have a look at how we can get started with chaos engineering. And first things first, let's hold our horses. Let's rail back before we even go anywhere near running a chaos engineering experiment. Let's do an environmental analysis, starting from the ground up with the infrastructure. What is running where? Are we running on-prem, in a private data center, in the cloud? Where we run designates what type of tests we run. Think about, I've had people say to me, hey, we run in a private data center. They're designed never to go down. I worked for a company once, and it was 4 months after I left. They were running in a private data, their entire infrastructure, running in a private data center in Dublin. That private data center had a 4-hour power cut. Their entire infrastructure was down. So we need to think about how things can possibly fail in these situations. Cloud. Regions go down in the cloud as well, right? We need to build these resiliency tests into our systems in order to achieve resiliency. But also, what are we running in those infrastructure? Are we running physical machines, virtual machines, Kubernetes, some sort of serverless architecture? How are we going to design our experiments to test that? When I started as a DBA, virtual machines were a very new thing. Have we got any DBAs in the room? Oh, wow. Okay, cool. All right, cool. I can say what I want. But we were all very, very like, I'm never running my stuff on virtual machines. Physical is the only way forward. But we now run, customers I talk to, 19% of them are running SQL Server on VMware. It's very rare I come across someone who's running on, say, physical infrastructure these days. And I was talking to another customer the other day, and they hadn't implemented any sort of SQL Server HA solution at all. They had standalone instances because VMware, the HA solutions in there, could provide them with their recovery point objective within their recovery time objective. So we need to consider what we're running and where. Kubernetes is a new one, containerization, especially for relational databases. It completely changed my mindset of working with, say, SQL Server. I'm used to, even with virtual machines, especially physical machines, we're used to whispering sweet nothings to our machines, nurturing them, patching them, fixing them when they go down. You don't do that with a pod in Kubernetes. Something's wrong with that pod, goodbye, gone. Because it changes the mindset, because it splits the compute from the data. Do we really care about the compute? Do we? No, we care about the data. As long as something can come along and access that data, we don't care what it is. So we can design some pretty cool chaos engineering experiments around that. Okay, next one. Applications. What's hitting our SQL instances? What is hitting, what is running, and where? How do the applications react to, say, the SQL Server instance going down? I've worked in a company where an AG failover from a primary to a secondary was considered an online operation. It's not. Mainly because when you fail over, any in-flight transactions get rolled back. However, the application developers had factored that in to their application. If there was a failover in progress and the application tried to hit the database, it would back off, wait, and then retry. So it was an online operation. I've also worked in companies where an AG failover just caused the app to start spamming errors like there was no tomorrow, and we had to go and restart it. So we need to know how our systems are going to react to, say, us running a chaos engineering experiment against the relational database. Okay, next one, monitoring. How are we going to analyze the results of our experiments? Okay, we can eyeball these experiments. We can just look at them and go, hey, yeah, that's pretty cool. But in order to gather as much information as possible, we need some monitoring in there. We want to get some actionable results from these tests. We want, how long were the instances down? Did they all come back up? How long were those databases in recovery? We want as much data as we can possibly gather. So we want to point our monitoring at the systems, say, even if it's in a lower environment, and gather as much data as possible. But here's a good one as well. Anyone ever been on call? Yeah, we got a few. We use Nagios. Nagios, when I first started at one company, was in our primary data center. What happens if that data center goes down? I'm going to get a good night's sleep is what's going to happen, because Nagios is down, it's not paging me at all. So we need to consider our monitoring solutions. Another really good one with stuff like that is, our monitoring solutions, are they HA? Are they located in a single point of failure? Things like that. And then, okay, finally, social. Hate to break it to you, we are a point of failure. How do people react to the systems going down? Has anyone here ever worked on a team where there was one person who was the font of all knowledge for a particular system? They installed the system, they maintained the system, they patch the system, they triage the system. They do everything with that system. How many people here have been that person? Hi. Take that person out of the room, metaphorically hit by a bus. Simulate that system going down. Does the rest of the team have the ability or knowledge to fix that system? If they don't, do they have the ability to get that knowledge, however it may be? It's a really good chaos engineering experiment. Cool. Okay, so after we've done our environment analysis and we're sure we've got no dark debt floating around in here, things like this are really important. I know it sounds a bit noddy, but who here has ever installed an application and there's a little checkbox that says, do you want to install an instance of SQL Express? Bane of my life. These little SQL instances popping up everywhere, and at some point they go down, and you're like, I don't even know about this. This is why things like environment analysis are important. Okay, so we've gone through our environment. Let's start looking at some chaos engineering experiments. Let's start looking at some failures that we can test with our chaos engineering experiments. So things like a past incident analysis. We go through the environment, we have a look at our ticketing system, our alerting system, what has previously failed in the environment, and what technologies and strategies were now put in place. Because we want to run tests that are actually beneficial to our environment. There's no point in running a chaos engineering experiment and going, hey, the systems reacted exactly the way we expected them to. And then some manager going, yeah, the chances of that happening are so small, it's never going to happen. You've wasted all of our time. We are never doing this again. No, we want something that's pretty likely to happen and that has an impact. So things like, okay, we had a standalone SQL instance. That went down. We brought it back up and decided to implement some sort of HA tooling, failover clustering, mirroring, still available, availability groups. How about we test how an AG fails over? Now, you can fail over an AG in SQL Server using T-SQL, but it's a real sanitized test. What about just turning off the primary instance and seeing what happens? I've actually run these tests in a production environment, and we did that. We turned off the primary, failed over to the secondary, no bother. Turned the primary back on, ran the same test again from the secondary to the primary. Didn't fail over. We had a misconfiguration in our Windows clustering that would only allow one failure every 6 hours. Missed that one. So when we do these tests, how are things actually going to fail? Not what we can run T-SQL and fail the AG over, great, but that's not how it's going to fail out in the wild. How will it actually fail? And then what was learned from those previous failures? Excellent stuff. Okay, so once we've done past instance analysis, we can then move on to some other techniques like a likelihood impact map. I'm terrible with slides. You have no idea how long it took me to make that. And it's still rubbish. Anyway, we gather our engineers into a room. We gather our team in a room. We sit them down and say, none of one's going home until we do this. And what we do here is we think about how the environment is going to fail. What's going to fail in the environment? And we rank it with how likely it's going to be and what the impact of it is going to be. Now this, from experience, the first 5–10 minutes is going to be like pulling teeth. But once you get a couple of out, the floodgates will open, and they'll start coming up with loads of different scenarios. And then you rank them on the map. And what you're looking for is 3 or 4 in the red areas at the top there. And these are your candidates for your chaos engineering experiments. From experience as well, some people tend to be overly positive about failures, and some people tend to be overly negative about failures. Guess which way I feel. And if that happens, you'll end up with all the points on the map clumped in one corner or the other. If that happens, you need to zoom in and do it again until you get that nice spread across the graph, and you've got 3 or 4 candidates for your tests. Cool. All righty. So, defining an experiment. Which failure has the highest likelihood? Which failure has the highest impact? And what will we gain from testing that failure? We want some actionable results here. Okay, if everything works first time, wonderful stuff. We've built confidence in our systems that they will react the way we expect them to when they encounter failures. And of course, this always seems to happen. When it's happened to me, I've had multiple times. 2 o'clock on a Sunday morning. It's never 4 o'clock on a Tuesday afternoon when I'm sitting there bright-eyed, bushy-tailed, ready to go. We want this confidence in our systems that, again, they will react the way we expect them to when we really need them. There is nothing worse than having to triage a failed disaster recovery failover, where half the stuff has come online in one site, the other half is still offline in the other site, and you need to work out what went wrong. Not a place you want to be in. We run these tests so that they react the way we expect them to when they encounter failures. And then there's a last point there. Is there anything else that can be tested? And it's a bit of an unfair question. It's like, is there anything you haven't thought of, Andrew? I don't know, haven't thought of it. What I mean by this is when you do your likelihood impact maps or gathering around running your tests, don't just stick to your initial team. So for me, it was DBAs. We got the system admins involved, the network admins, the end users, because I guarantee you they will come up with scenarios that you won't have thought of, especially the end users. They'll come up with some weird and wacky stuff. You'll be like, gee, all right, let's run those tests. Because we want, again, to get some real gains from doing this. We want as much benefit as we can possibly get. Okay, so to round the session off, a little bit early, but I want to talk about an example implementation that I ran at a company I was working at. And this is SQL Server running on Kubernetes. I was working at a company once, and our QA environment had problems refreshing. Every month they wanted to blow away all the test VMs, rebuild them, redeploy SQL Server. Now, because of the spec of the servers these were on, it took around 45 to 60 minutes to spin up a new VM, install SQL, get the data working. Not great. So what we wanted to do was we took the install of SQL away, deployed it on a host running in Docker containers. So when we refreshed the QA VMs now, the new VM came up, kicked off a Docker container, and referenced that from a custom image with the databases that were schema only, ready to go, and then we pumped data into it. From 45 to 60 minutes per VM, the longest it took us to get a new VM up hitting a SQL Server container, 2 minutes. A massive gain. We actually worked it out. It saved us about a month's worth of dev time per year. However, we were running Docker on a single host. 3 guesses what happened. Came into work one morning, that host was down, no one could do any work. Didn't have any sort of HA solution put in place. So I wanted to start looking at an orchestrator. SQL Server running on an orchestrator. That would give me that built-in high availability. SQL has no native HA solutions that work in Kubernetes. Availability groups don't work, mirroring doesn't work. They work, but you don't get automatic failover, and so what's the point? So you have to rely on the orchestrator for you, and Kubernetes really did win the orchestrator war. Anyone here doesn't know what Kubernetes is? Cool. So as we know, Kubernetes has this concept of desired state versus running state. We define our desired state in manifest files and deploy them into Kubernetes. At that point, they become our running state. And so if anything happens to the running state, there's a feedback loop, reconciliation loop built through controllers, multiple ones of them, that will go, hey, the running state no longer matches the desired state, and fix it automatically for us. And so I went and built a proof of concept of SQL Server running in Kubernetes and showed it my boss, hey, look, I'm killing these pods, and Kubernetes realizes the running state no longer matches the desired state and automatically fixes it for me. It was great, but this is a brand new technology. We need to get senior level board management in on this, so you're gonna have to show that demo you just showed to me, but you did it all through code. Could you like jazz it up a little bit? Like jazz it up. Jazz hands? He's like, no, is there any sort of web GUI that you could use? Like web, all right, well, okay. Find a jazzy web GUI to demonstrate high availability for SQL Server on Kubernetes. I've had some weird remits in my time, but okay. So I went off and went and found probably my favorite GitHub project ever, and went back to my boss and said, okay, how about this? I can demonstrate high availability for SQL Server in Kubernetes using Space Invaders. And as you know, the invaders are pods. They are the SQL instances. And we play as the ship, and we're killing them, and we can see the pods being redeployed. The running state no longer matches the desired state. Kubernetes is automatically fixing it for us. And this is how I demonstrated high availability for SQL Server in Kubernetes to the senior management of my company. You may or may not be surprised, I no longer work there. Anyway, that is it from me. I've got a whole bunch of resources for you here. Thank you so much. If you have any questions, please feel free to reach out.
I love the way that he was able to drop those golden nuggets, but also keep you laughing as well and engaged. So well done on that, Andrew. Thank you very much.